Welcome to all. Myself Dr. P.R. Krishnaveni. Today's lecture is on diesel knocking. In the earlier lecture, we had discussed about petrol knocking. So, in this lecture, we will discuss about diesel knocking. So, again coming to the brief discussion about knocking. The internal combustion engine converts chemical energy into useful mechanical energy by burning fuel. An internal combustion engine uses either gasoline or diesel as a fuel. The ignition is brought by means of electric spark or by compressing the air. The ignition is brought by means of electric spark in the case of petrol engine and by compressing the air in the case of diesel engine. In diesel engine, the fuel is ignited not by a spark as in petrol engine, but by the application of heat and pressure. So, this you can understand by discussing the 4-stroke diesel engine. So, the combustion cycle has 4 strokes. So, the first one is the intake stroke. So, this intake stroke can also be called as suction stroke. So, in the internal combustion engine mainly consists of an intake valve. This is the exhaust valve. This is the cylinder which consists of fuel air mixture. This is the piston. This is the connecting rod. And this is the crankshaft. So, in suction stroke, the air will be drawn into the cylinder, and the second one is the compression stroke. In compression stroke, the intake valve and exhaust valve are closed, and here the air will be compressed to a pressure of 30 to 50 kg per centimeter square. So, here air will be compressed to a pressure of 30 to 50 kg per centimeter square. So, due to this compression, the temperature of the air will be raised to 500 degrees centigrade. Next one is the power stroke. This is the 3rd stroke. Here the cylinder is filled already with hot air, and now this air will be compressed with the piston to the top center. As a result, the fuel, nothing but what? Diesel, will be sprayed as fine droplets, and it will absorb the hot compressed air. So, when the droplets absorb the hot compressed air, the diesel starts igniting. So, due to this ignition, pressure will be developed and it will pushes the piston downwards. And the last stroke is the exhaust stroke. here the exhaust gases, nothing but what? The hot air gases will be sent through the exhaust valve. This is how the internal combustion diesel engine will be working. Next, diesel knock. A diesel engine starts by the compression of the fuel and air mixture in the cylinder, as already we had discussed earlier. Due to the composition of the diesel fuel, sometimes fuel does not undergo ignition on application of compression called ignition lag and produce rattling sound. Diesel knock can be defined as the rattling sound produced due to the delay in the ignition of the fuel called ignition lag. C10 number or C10 rating. The extent of diesel knocking can be measured by using an arbitrary scale called C10 number or C10 rating, whereas the petrol knocking, as we had discussed in the earlier video, petrol knocking is measured by using an arbitrary scale called octane number or octane rating. In the case of diesel knocking is measured by using the arbitrary scale called C10 number or C10 rating. It is actually a measure of the fuel's ignition delay. C10 has a very short ignition delay as compared to any diesel fuel, hence assigned an arbitrary value of 100. Alpha methyl naphthalene has long ignition delay as compared to any diesel fuel and hence assigned a value of 0. So here C10 means nothing but N-hexadecane. This N-hexadecane is called as C10. So N-hexadecane structure is CH3, CH2 14 times, CH3. This is called C10, and the C10 number of this one is 100. And alpha methyl naphthalene has long ignition delay. Alpha methyl naphthalene means its C10 number is 0. This is alpha methyl naphthalene. C10 number of a fuel is defined as the percentage of cetane in a mixture of cetane and alpha naphthalene which will have the same ignition characteristics as the fuel under test under the same set of conditions. Cetane value of a fuel depends on the nature and composition of hydrocarbon. Hydrocarbons which are poor gasoline fuels are quite diesel fuels. Thus, the order of cetane number is N-alkanes greater than, naphthalene greater than, alkanes greater than, branched alkanes greater than aromatics. So, if we observe this order, this is nothing but what? These are the poor gasoline fuels. So, they are quite what? Diesel fuels. Cetane number of a diesel fuel can be raised by adding small amount of ethyl nitrate, isoamyl nitrate, acetone peroxide, etc. Whereas the octane number can be raised by using methyl tertiary butyl ether. So, there what is the advantage of using methyl tertiary butyl ether means, in the earlier video already I have told you, their oxygen will be existing in the form of ether group, which is helpful in oxidizing the fuel. Thereby it prevents the formation of peroxy compounds. High speed diesel engine require diesel with cetane number 45 to 60. In high speed diesel engine, the time lag in getting diesel droplets heated to ignition point is very small. Nearly 1 by 500th of second. That's why it requires diesel with cetane number 45 to 60. For low speed diesel engine requires diesel with cetane number of about 25. For high speed diesel engine, cetane number with 45 to 60. For low speed diesel engine requires diesel with cetane number of about 25. If we take medium scale or medium speed diesel engine, it requires diesel with cetane number 35. Now coming to the differences between gasoline and diesel engine. So coming to the fuel used in the gasoline engine. In gasoline engine the fuel is gasoline plus air, and in the case of diesel engine the fuel is diesel plus air. And ignition. In gasoline engine, ignition is brought by spark plug, and in diesel engine, ignition is brought by compression of air. And coming to the knocking, petrol knocking is attributed to pre-ignition of the fuel, and diesel knocking is attributed due to delay ignition, or this can also be called as ignition lag. And the fuel characteristic expressed in octane rating, and here in the case of diesel it is expressed in terms of cetane rating. Here it can be called as octane rating, or it is expressed as octane number. And here it can be expressed as cetane rating or cetane number. And the additives which are used to reduce the knocking. Petrol knocking can be reduced by adding tetraethyl lead and lead telluride. And the diesel knocking can be reduced by adding ethyl nitrite, isoamyl nitrite, acetone peroxide, etc. In the case of petrol engine, due to the addition of tetraethyl lead, lead peroxide will be formed in the internal combustion engine. When it is deposited in the internal combustion engine, it becomes harmful. So that's why in the place of tetraethyl lead, diethylene bromide may be added. Thank you.